Total hardness. This video will show the proper method for collecting water samples and conducting a test to determine the total hardness of a water sample. When monitoring in coastal waters, conduct a salinity test first. If salinity is detected, do not perform the hardness test. For this test, you will need the hardness tube, code 4488, hardness reagent number 5, code 4483-E, hardness reagent 6 tablets in a blister pack, code 4484A-J, and hardness reagent 7, code 4487WT/H. Remove the hardness tube from your kit. Rinse the tube 3 times with water from the site you are sampling. Fill the tube with sample water. Hold the tube at eye level and flick out excess water until the bottom of the meniscus touches the 10 ppm line. This is your 10 parts per million, or ppm, sample. Locate hardness reagent number 5 bottle. This bottle has a built-in dropper, so uncap the reagent bottle. Gently squeeze it in the upright position to let some air out, and then turn the bottle upside down while releasing the pressure. When dispensing the reagent, take care to hold the bottle vertically. This ensures uniform size drops. Add 5 drops to your sample and gently swirl to mix. Locate the hardness reagent number 6 tablet blister pack. This reagent is in tablet form and is very soluble. Take care not to touch the tablet or allow any water to come into contact with the tablet prior to dispensing it into the hardness tube. Hold the blister pack with the foil facing down over the opening of the tube. Press on the opposite side of the blister pack to dispense a single tablet into the water sample in the tube. Carefully cap the tube with the large blue cap. You will only need to partially cap the tube. Pressing the cap down completely on the tube could cause the glass tube to break. Gently swirl the tube until the tablet dissolves. Typically, a pink color develops as the tablet dissolves. Next, we will titrate our sample using hardness reagent number 7. The hardness reagent number 7 bottle also has a built-in dropper, so uncap the reagent bottle, gently squeeze it in the upright position to let some air out, and then turn the bottle upside down while releasing the pressure to create the vacuum to give you more control over the drops. When dispensing the reagent, take care to hold the bottle vertically. We will count how many drops of hardness reagent number 7 it takes to cause the sample to change to a blue color and to stop changing color. In other words, we will reach the titration endpoint. Add 1 drop of hardness reagent number 7 at a time to the water sample in the tube. Gently swirl to mix between each drop. Be sure to allow time between drops for the color change to occur, especially during cold weather. You will need to know how many drops you add to your sample, so don't forget to count. You can keep the bottle in the vertical position throughout the test. Continue adding single drops of the reagent until the pink color changes to blue and the additions do not cause a color change. Once you think you've reached the titration endpoint, or the point where the color is no longer changing, add 1 more drop. Do not count the last drop if there is no color change after its addition. In some cases, the sample water will turn blue after the hardness number 6 tablet dissolves prior to titration. This could indicate that there is no measurable hardness. However, you will need to titrate to confirm that no color change will occur with the addition of hardness reagent number 7. If you add a single drop of hardness number 7 and no color change occurs, record 0 mg/L for total hardness on your data form. On the data form, record the number of drops it took to reach the titration endpoint. Also on the form, to calculate a total hardness value in milligrams per liter, multiply by 10 the number of drops of hardness reagent number 7 used. Note that if total hardness routinely exceeds 200 milligrams per liter, conduct the test by filling the hardness tube to the lower line, 20 ppm, and multiply by 20 the number of drops of hardness reagent number 7 used.